text that can render on screen. And you would see that it shows that this is some random text that can render on screen. Hello again, Demonari here, back to the game engine project. This is part 2. I made a few tests and runs to basically have a cleaner setup for rendering and updating. This is going to be used in this new project, GL Engine Part 1. This is a copy of the original project. We're going to use this to write something that can handle textures and text. The project is going to be called Clean Render Buffer. Set as startup project and close everything. Okay, inside the folder code, we're going to add a new header. This header is going to be called Render Buffer. It is going to use the render pipeline objects in order to make something that is more clean to use and requires a lot less interactions. So we'll start class render buffer. This class is going to include a VBO and a VAO. We are also going to save the vertex attribute array and use this class as a template to always have the correct amount of data. We don't want to separate things into separate containers. We want everything to be contingent in memory. So we're going to make our setup buffer, basically setting up our render buffer. Just write everything. This is going to include the setup for both the vertex array and a vertex buffer. Later on, I will realize that I need a few more things to be saved as private members, but currently just having all of the data updated and rendered through a pipeline. Render data is also going to have the glint to describe the stuff that it needs to render. We added an elements to remember how many elements were last inserted into the array, so we know how to render exactly how many of them. We will also have a release render buffer and a distractor. Adding a distractor means that we also need to add a constructor, and the constructor is going to be trivial, just having the trivial constructor values. We are going to set up things based on the type. This is going to require a fix later because an enum needs to be initialized as an enum. We're going to change our level to use render buffer, so it has only one element to it, and buffer have everything set up basically at that 14. It should be instantiated, and we should start setting everything up. So yeah, because it has only one vertex element, making the init buffer, we just go to our old project that's set up to get some reference to what is actually needed in order to render. We see that we make the buffer, bind it, then set up the array, and then we set up the buffer layout. The size of is the stride, and we will need to save that stride somewhere. No, we don't need to save the usage is saved. We save the attributes, attributes I equal to attributes I. So later on, when we actually do the updating, we will have that saved, and then we unbind both. When we update the data, we bind both VAO, VBO, then set up the buffer, then update the buffer. Oh, right, set up the layout and then update the buffer. And this is when I discovered that I need to remember the stride. So as another thing, I added the stride, and stride mstride is equal to stride. Replace everything with mstride, then use mstride in the new updates. We already get data and number of elements. Now we need to save the number of elements for the time that we render it, but I'm not sure if I remember that. Alright, I try to remember if I want to do it like that or in another way. There are two static functions that we want. One is going to be end operation and the other one is end render. End operation is going to unbind both the vertex array and vertex buffer, and end render is going to only unbind the vertex array. This is when we use multiple of them and we want to avoid collisions with other things outside of the update and render logic. So we unbind everything that those elements use, but we don't do it between operations on different buffers, only at the end of an operation that includes those buffers. And these elements here, I added m elements, and now starting with the render data. Render data is just bind VAO and render by draw arrays. Yeah, so now I added the draw type, and now it can handle stuff that is outside of the GL draw points. And we have draw the entire array. We might want to introduce another type of draw function which draws only a partial buffer, but that would be for another time. Now going into the release buffer, we make it so that it would call the VAO release and the VBO release, functions that don't exist yet, but would exist in a little bit. We also add an end operation before that to not have those buffer accidentally bound when we release the render buffer. Capitalize those functions and go on. So let's go to vertex array and void release, and then the destructor just calls the release function. Now we replicate that for the vertex buffer, and there we have VBO didn't do it correctly the first time, but this is the correct way. And now the element buffer, and yeah, it's still delete buffer, and let's remove the original element buffer, and now everything should work fine. Not only that, but we also have release functions. So let's start setting up mbuffer, init, render buffer, the usage, the data, and of course the amount of vertices. We can set all of those up. We also set all of the shader data. We have release render buffer in the unload. We didn't add the release shader yet, but we will do that eventually. Data GL points. Now, does it render? Okay, why? Oh, because I completely forgot about this. Now it should work, hopefully. Yes. So now that we have our render buffer set up inside our level, and it is exceedingly simple. It is literally an init, an update, and a render. We can go and move on to updating our shaders. First, we'll start by fixing a little bit of a problem. You see, I hard-coded the screen height and adjusted the Y position because my rendering is incorrect. What I should do in my vertex shader and later on my geometry shader is instead do this. A pos F is actually changed into this. For A pos X and screen height minus A pos Y. Additionally, A pos Z replaces the sprite index and input of a pause is replaced instead with an IVEC3. Let us now change the appropriate data to reflect that change. And do that. Vert amount times 3 instead. And those are all the current changes. It should still render properly right now, but let me check. Right, we forgot to change those. Well, this is 1 times 3 plus 0. This is 1 times 3 plus 1. This is 2 times 3 plus 0, and this is 2 times 3 plus 1. They are now updating correctly, and they also allow for whatever textures I want. This is still not showcasing the correct way, so let us go through our geometry shader. You might see that the geometry shader got a few changes. First, sprite size was separated into its new parameter, which is going to later on be passed on through the VS out, not the VS out, yeah, through the VS out of the vertex shader. So this is one thing. Another change is this and this. What exactly am I doing here? Well, due to the fact that the y-axis is inversed, the textures got rendered in the wrong position. And now, with inverting the y-axis through the geometry and vertex shader, we can render everything properly. Next up is importing the game font and texture image. I'm gonna do those and then I'll be back. Okay, so inside content, we're just going to drop those and we're going to drag them into content. Pause all of those content through, at least for now, so that we have our stuff. Let us go and look into the texture classes, and we see that bind to text was added. What we did is made a surface, free the surface, and then unbound. Then later we bound them to text on the shaders. So now we need to update the old texture class to the new one. The only real change is the addition of the bind to text. Other changes might be minor things like moving the binds and stuff like that, but beyond that there is no real change. Bind to text is just binding, setting active GL texture and then binding, and bind is just GL texture to the text inside the bind texture normally. So that is all there is to it. In our level, we're going to make texture, and we're also going to include texture. We will also add true font. True font is only useful inside the loading function. Outside of making the basic font texture, we are not going to use the actual font file. Let us set up the texture. Let's add this. So we're going to load a surface. We're going to make the texture from that surface, and then we're going to free that surface. We're going to add this text, my text slot, and now inside our fragment shader, we added this. Is everything working? Yes. Now let us change that back to I, change vert amount to 4, and as you can see, it draws the entire texture separated into sprites of 2 by 2, and we can change them in real time. Everything works perfectly, and everything is actually perfectly segmented as well. So what we're going to do is we're going to add a texture shader. We're going to add the text shader, and this means that our texture and shader have shader text and texture text. In our level, we are going to also make that but instead it's going to be shader underscore text, going to be for that. Let's add another here in 16 char list 256. Now let's compare what we did here, because I'm still kind of iffed about this. We're going to load a font. We're going to return true if it fails. So if load font fail, we failed at loading the font and we're in trouble. But if we didn't, well, we can make a glyph atlas using that temporary font with the char list, and then we can unload the font. After we unload font, we can make a string array, but what we want to do is we want to make the texture. So we are going to have our text made from that surface, and then we're going to free that surface. This text info is going to be very useful, right? And this is when we change our approach here and we actually add the true font into the header. Right, I completely forgot that I added that singular data structure later on. In the true font header, there is glyph atlas info. Now this should work. That is going to, this text info, this glyph information is going to be later used when we are going to generate strings that would use this texture. We're going to be rendering using the shader text and the text texture using an array that is generated by the text info. So let us make such an array. Max string 200. Okay, and that is 1, that is 2, that is 3, and those are going to be painful. Okay, not as much. Okay, text slot is going to be 1. Normal texture is going to be this. Glyph grade, the amount of columns should be X. The amount of rows should be Y. This is still the size, and texture is my text slot, and text should be bound to this. Let us see if everything still renders correctly. Yeah, I messed up. Location redefinition, and I done goofed because font didn't load. Right. There was one difference that I remembered adding when dealing with this part. We need to go into controller and our level to see how, also into load font, to see how this is different. It is not. So the difference is with those image init, TTF init, and mix open audio. We are going to use those functions in order to allow SDL to actually utilize the image through text font and open audio with SDL into controller. Right after SDL init, we're going to do those, because in the unload, in cleanup, we already quit those 3 functions. There is no additional things we should add. Now with TTF init, things are working again. we get our font, and now we need to set up something to render it with. Let's go back to our level. Let's add a second render buffer message. What we're going to do is we are going to init render buffer for message the same way we did here. We're going to change this to dynamic draw. It's not going to make a real difference. Those are only suggestions. Dynamic draw is for buffers that you're going to update a lot, and static draw is for buffers that you are going to update only rarely. Let's start with making message. Message is now existing. This render buffer, points, and instead of shader, it's going to use shader text. We're not going to update it. Another thing, we should add GL enable, GL blend. And another thing is we're going to tell it to use blend func, source alpha, and 1 minus source alpha. This is going to make text show up. Not really, because we're not rendering any text as of this moment. With buffer set up, let us ready a message. Okay, size of message should be 12. Yes, we can do it like this, and we can do it while message I. So while the message is not complete, continue reading the message. Position X is 40. Position Y is also 40. And let us go into mstring. Also int count equals 0. Count plus plus. Instead of count, we close this. We go into mstring. Mstring 3 times I plus 0 equal position X is position Y, and that is message I. Now, currently our atlas is using exactly the ASCII table, so we are not going to need any lookup functions to translate. That's why message I is directly translated into the glyph ID. Later, glyph IDs would be not correlated and would use some sort of search function. In order to find out the advance, we do glyph database message I advance, and we take our expose and increase it by the advance. Then we take the message, we update the data with a count of elements m string. Of course, we need to remember to convert it to char pointer, and that should draw everything correctly, and it crashed. What did I forget to do? Instead, let's set it like this, and instead of filter amount count. Okay, there is some drawing going on. There is some bugs as well. So let me see what's going on. Why is it the size of... Let me look at what the fuck is going on with the glyph DB. Okay, let's look at it like this. This should still work. Okay, so now everything should work fine. Wait, or delete controller, unload. Oh, it doesn't matter, it's a cleanup. It's some dumb shit happening in the cleanup. So, now that everything is like that, we need to fix the dumb thing I did in the true font. So, in the original implementation of the true font, I did a lot of stupid things. So let me fix those. In the font header, I added 2 private functions called myMetrics and myData. So those should fix everything, but let's go over everything that happens. When we create a font, we make mFont equal to null, so we know that it's empty. In font, when we unload a font, we call unload font. When we load, we try to open it with the TTF open font, and we return true. When it fails, unload font checks if there is a font and then closes it and set itself to null so it wouldn't try to close an already closed form. When we make a glyph, for some reason glyphs are y-axis normalized, and they also have offsets that can be negative. That is something that completely broke my code. Trying for those, I set the correct pixel padding and start doing to the destination, which is the data size in the packed location. And data size is of course calculated by the maximum minus the glyph offset. Now everything else is just normal, and because of course it is the advanced not set correctly? Heap corruption detected. So let's do this and instead do this. Else. Okay, this should be fine. Glyph ID and pushback of surf. Okay, so now this should be fine, and it prints hello world with the correct advances. Thank. This is because we're using an ASCII map and we're not using a search. If we were using a search, it would have worked the first time, but currently, god fucking damn it, what is the heap corruption? Okay, I currently have some memory leak that I caused by some dumb action. So there should be something stupid I did. R level, which is 304 bytes. That sounds wrong. Oh, yeah, of course it's wrong, because that is the corruption. mstring doesn't have the max string. Now when we close, yeah, this was the memory leak. That is a correct size. I set only 4 vertices for our string, and that is not how many vertices we actually used. Because we used more, then we were allowed to use it because the heap is big and we didn't collide with anything. But it caused a memory leak because we accessed and modified areas of memory that do not belong to us. Now, with max string actually set correctly, we can work on everything as it should. Now in load, what we do is if I, not here, in here, and I is smaller than max string. Yes, this is some random text that can render on screen. And you would see that it shows that this is some random text that can render on screen. Great. Now, what do we do with the text shader? Well, text shader can have a uniform called text color. And with that new uniform, set float 3, I think. Yes, it is a set float 3. And now this should be, I messed it up. Oh, right. We need to remove this, and now this should work. Yep, now we have colored text. So this is basically it. We can now render text messages on the screen. We can render textures with Sprite. We do it very cleanly. This is everything for this stage of the game engine. We even have a random character string to a simple single line text. This is enough for most languages. This way of rendering the text by generating the sprites for the characters directly is actually very, very nice. So for that, I'm done.